Okay. We have these equations we want to solve. And of course, you should know this conversion. You shouldn't have to look at anything. You should have that clear by having done a number of problems, okay? So you have to be used to using this conversion. Now, people are doing fairly well with the conversion, although there's still some errors going on. Okay, so we got 2 to the x minus 5 equals 3. Okay, well, I'm going to use colors here. And this is of this form, isn't it? Okay, because it's like 2 corresponds to B. A is the exponent, it's x minus 5. And C is the number on the other side of the equal sign. So people are having trouble identifying these, so you really have to do whatever is necessary so you can see where things are. Okay, A is the exponent. Okay, and of course, everybody knows what an exponent is. B is the thing that's raised to the power. That's 2. And C is on the other side of the equal sign. So you can match this equation up with this rule. Okay. Now, where does B go? B goes here. A goes here. And C goes here. So maybe the colors help, maybe they don't. But this is of this form with A equal to C, x minus 5. G is equal to, and C is equal to 3. Again, I'm just those letter B. There's A. There's C. Ignore the colors, we don't find the colors. Just look at the position. You got a base, you got an exponent, and you got it equal to something. So the base is 2, the exponent is x minus 5, it's equal to 3. So A is x minus 5, B is 2, C is 3. Now we write it in this form. Log to the base 2 of 3 equals x minus 5. Okay, again, whatever it's worth, there's your A. Everything matches up. This form, down with this form, if we use these numbers, right, or these symbols for A, B, and C. Okay, so now we have log base 2 of 3 equals x minus 5. Do we have 5 for both sides? Why do we have 5 for both sides? Because that's going to give us x. So x equals log base 2 of 3 plus 5. And we usually want to write x on the left, so we say x equals log base 2 of 3 plus 5. Now, of course, you have another rule, which is log base b of quantity is Q quantity. Let's say for the log Q, for the log of theta. And you have a log button on your calculator. So finally, x equals log of 3 divided by log of 2 plus 5. You can punch that into the calculator. Now, if you've got a log base button on your calculator, you can get this without using this rule, but that's not going to help you on the test because you're not going to have a calculator with that log base button. So you're going to have to use log base B of Q is log Q over log B. And they're important connections. It's something you don't want to lost. So that's the way you would write out the solution. And now you can punch it in your calculator. Okay. Now the second equation. Well, times 3 to the x equals 4. Is not in this one. It's not a b to the a equals c. I mean, right there's a b to the a equals c, but it's got a 12 in front of it. And there's no number in front of b here. There's nothing in front of b, but there's a 12 in front of 3 to the x. Okay. So what are we going to do about that? We don't want that 12 there. Well, we divide both sides by 12. We got 12 times 3 to the x divided by 12 equals 4 divided by 12. So 12 into 12 is 1, so we just get 3 to the x. And 4 divided by 12 is 1/3. We don't want a decimal equivalent here because it's an approximation. Okay. Now, 3 to the x equals 1/3. Good. This is now in this form with a equal to x, b equal to 3, and c equal to 1/3. So now we just look at this form. We see we have log base b, b is 3, so it's log base 3 of 1/3 equals x. So x equals, write it out with x on the left. That's not necessary, but people like to see it this way, and you probably do too, so I'm going to write it out this way. Okay. So x equals log of 1/3 divided by log of 3. Now you can't divide the 1/3 by 3 because the log function applies to the 3 with 1/3, and that's just not going to work. So you have to do that. You just punch this in your calculator now, and you're going to get it. There's more that I'd like to say about that, but that's going to be sufficient. Okay. Now, we have 3e to the 2x plus 1 equals 2. What are we going to do about that? Well, it's not of this form. Now, the reason we use this conversion is because if we look over here, x was in the exponent, right? X was the exponent. In this case, it was in the exponent here. Okay, you can't get to it when it's in the exponent. You got to bring it out so that you can do the algebra with it. Okay, so we have to convert to logarithmic form. Again, the x is in the numerator. So we can identify them. Well, we don't identify them. Now, the problem is we have a number e to this exponent equals 2. Now, e is a very specific number. It's a very important number, maybe the most important number in the universe. Okay? So it's really important, but you're not going to, in this course, fully appreciate why it's important. Okay, so what do? That 3 is in the way. That 3 prevents it from being in this form. So we have to divide both sides by 3. And now we can write this as e to the 2x plus 1 equals 2/3. Now it's in the form. So we see that a is 2x plus 1. B is e, and C is 2/3. So now we can write it in the logarithmic form. It's log base b, so it's log, what's b? B is e, log base e of C, which is 2/3. And that equals A, which is 2x plus 1. Now let's go ahead and put this form. Haven't really changed the form, we just got dx on the left where we prefer to see it. Okay, now we have to just do the arithmetic. We need to isolate x, meaning we have to subtract 1 from both sides. Giving us 2x equals log base e of 2/3 minus 1. So we divide both sides by 2. So we have this. Getting degrees x equals log base e of 2/3 minus 1, all divided by 2. Now, if you've read the materials and seen the open math stuff, and some people a little bit behind, so not everybody has, log base e is the natural log. So we can write this as natural log of 2/3 minus 1, all divided by 2. And you have a natural log button on your calculator. So you don't need to use this rule when b is e. And then punch that in your calculator. And of course, then you want to go back and check. And people are slow about checking. Okay, so try to get used to the idea that the way you learn this stuff is by working things out and checking. And then if it doesn't check out, you immediately know that you need to fix something. So you got to figure out what to fix. Okay. Now, this fourth equation. Get that in here. Just adjust the camera a little bit. Okay. So we got log base 2 of x plus 5 equals 4. Okay, well, this is in this form. What's B? B is the base of the log. Not true. Let's see. Yeah, not so much to the left of that, kind of. Okay. So I'm gonna write it out here. B is 2. C is what you're taking the log of. C is x plus 5. And A is 4. So what do we have? It's visible. We have B to the A equals C. B is 2. A is 4. C is x plus 5. So we have x plus 5 equals 2 to the 4. Well, we subtract 5 to both sides. Then we get x equals 2 to the 4th minus 5. Of course, 2 to the 4th is 16. This is 11. We check this as we always do. If we plug 11 back in here, we get 11 plus 5. So log base 2 of 11 plus 5, which is 16. Log base 2 of 16 is 4. And since 2 to the 4th equals 16, that's what we saw. They don't check out. Make sure the rest of these check out. It's possible I made a mistake. I haven't done the check. I'll do that to you. Okay. Now this last problem. Log base 3 of 2x minus 3 equals 3. We see that we have a log base b of something. So we have a log base b, we have a c. We have an a, but we don't have a yet because we got a 4 out in front of the log. We can't have a 4 in front of the log and use this conversion. We have to have exactly this form. So we divide both sides by 4. We get log base 3, 2x minus 3 equals 3/4. We convert this. We identify b equals 3, c equals 2x minus 3, a equals 3/4. So now we have b to the a, which is 3 raised to the 3/4 equals 2x minus 3. Well, that's right, 2x minus 3 equals 3 raised to the 3/4. And we add 3 to both sides. And we get 2x equals 3 to the 3/4 plus 3. Divide both sides by 2. get x equals 3 to the 3/4 plus 3 divided by 2. And that's an expression you can easily plug into your calculator. So it all comes down to number one, being able to get an equation into this form or this form, and then simply converting the form. Okay. Okay. This was done earlier in the course, so I probably need to refresh your memory. Two possible things we can do. We can graph these two functions for these two equations and determine where they cross. Or to get an accurate solution, that's what we're going to concentrate on right now. Of course, you need to be able to graph these and check the crossing point. But now we need to refresh you on how to solve these. We're going to call this equation 1. We're going to call this equation 2. Now I might be, just a little bit off the board. I'll arrange the camera, whatever. Okay, so this is equation 1, and this is equation 2. Now, I write -2 times equation 1. So I multiply every coefficient for every number in equation 1 by -2. That gives me -4x minus 6y equals -10. And then I write down equation 2, which is 4x minus 2y equals 2. And now I do equation 1 plus equation 2. Where equation 1 refers back to the first equation in this step. It doesn't refer all the way back to this step. In other words, I'm going to add these two equations. Now, can you do that step for me? Okay, now I've drawn a line here because we've used this scheme before, but I'm not saying what people really remember. And maybe I'm not sure people understand what's going on when I write these things down. Okay, I'm saying -2 times 1 with a circle means you multiply -2 times the first equation in the previous step, right? So that's why I got the -4x, -6y, -10. -2 times 2 is -4, -2 times 3 is -6, -2 times 5 is -10. Why did I do that? Well, now if we add these things up, we have -4x and 4x. Well, that's whatever 4x is, this is the negative of it. If I add the negative of a number to a number, I get 0. -4x plus 4x is 0. Now, -6y and -2y is -8y. And -10 and -2 is -8. Rewriting that, I just have -8y equals -8 because I don't have to write down 0. 0 minus 8y is the same as -8y. Okay? And now I can solve this. I get -8y over -8 equals -8 over -8, which gives me y equals 1. Now that I have y equals 1, I take this and I plug it in to either first or second equation, first or second original equation. So I'm going to go with it first. I'm going to plug one in for y. This gives me 2x plus 3 times 1 equals 5. Can you solve that equation for x? Okay. Well, we have 2x plus 3 times 1 equals 5. 3 times 1 is 3, so we can write this as 2x plus 3 equals 5. Try to solve for x, we got to get rid of the 2, 3. And basically, we always get rid of things that are added or subtracted before we get rid of things that are multiplied. So we're going to do 2x plus 3 minus 3 equals 5 minus 3, which leaves us with 2x equals 2. We divide both sides by 2. We find that x equals 1. Then we check that. We write these equations out with x equal 1 and y equal 1. Well, 2 times 1 is 2, 3 times 1 is 3. So 2 and 3 is 5. That works. And this is also going to work. We should write this up. Okay. Okay, well, I've changed the order of assignments, and you're going to need to be able to follow this process. Again, we did it earlier in the semester, back when we were doing linear equations. So you might want to review that, or at least let Open Math refresh you on the steps. Okay. So let's see how you can do with that for next time.